All right, I will try to elaborate on the mango problem. So, what is really happening in this question is they have given a wall, all right, and they've said that there are two mangoes on the opposite sides of the wall. Is that clear? So, in this sense, there is a wall, and there's mango 1 and mango 2 on the opposite sides of the wall. Fine. So what they've given in the question, what they've asked us in the question is they've asked us the real distance between mango 1 and mango 2, right? And they've said that mango 1 is 1.5 meters above the ground. So I can take the relative positions from mango 1 and mango 2 with the wall arbitrarily, which means mango 1 is in one side of the wall and mango 2 is in the opposite side of the wall, right? So this is one side of the wall and they're saying mango 1 is 1.5 meters above the ground. This is the ground, correct? It is 1.5 meters above the ground. This is the elevation of mango 1 in respects to the ground. Mango 2 is 3 meters. This is 3 meters above the ground. Now I have taken the scale as 1 meter equals 20 mm. So 1.5 meters becomes 30 mm and 3 meters becomes 60 mm above the ground for mango 2, correct? Now they've also mentioned that mango 1 is 1.2 meters from the thick 0.3 mm thick wall. So 0.3 mm is 0.3 meters, 6 mm wall, right? So from that wall, it is 1.2 meters. 1.2 meters in the sense is 24 mm. So mango 1 is 24 mm away from the wall, and mango 2 is 1.5 meters away from the wall, which is 30 mm apart from the wall, away from the wall. So they've given the distance of mango 1 and mango 2 from the wall, and they've given the elevation of both the mangoes. And what they've also given is the horizontal distance between mango 1 and mango 2. That's my mango 1 and that's mango 2. They've given the horizontal distance between mango 1 and mango 2 to be equal to 52 mm, right? That is 2.6 meters or also 52 mm. Now, what you do in all these application-based problems is you convert this entire problem into top view and front view, correct? Now, in an XY line, this is going to be my front view. This is going to be my top view. So when you look at this whole wall from the front, what am I going to see? I'm only going to see the elevation of mango 1 and mango 2. I'm standing here, alright, and I look at the wall and I look at these mangoes. I only see the elevation part of these mangoes, right? And that is what is listed here. Mango 1 is 30 mm, 30 mm tall from the ground. It's from the ground 30 mm. So from the ground 30 mm. This is mango 1, and mango 2 is from the ground it is 60 mm, which is from the ground it is 60 mm. So from the front view I see the elevation which is properly depicted here. And what is also to be noted is the horizontal distance between the two mangoes is listed to be 2.6 meters or 52 mm, which is also reflected here. This is my front view. What happens in the top view now? In the top view, when I look from the top view, how is the top view going to look like? I'm here right now, and when I look from the top, I basically see the distance between the mangoes and the wall. So when I see from here, I see M2 to wall distance and wall to M1 distance. I see the relative distance between the mangoes and the wall, which is also clearly listed here. You notice of M2 is 30 mm away from the wall. So I've basically taken arbitrary position for M2, and I'm like M2 is 30 mm. I draw 30 mm line, and that is where my wall is located. Okay. Now M1 is 24 mm away from the wall. So this is the wall. 24 mm away from the wall will give M1's position, correct? So when I look from the top, this is the wall. I get the relative distance between the mangoes and the wall. This mango 1 to wall, mango 2 to wall, relative distance. And they're in the opposite direction of this wall. This is the wall, and mango 1 and mango 2 in the opposite direction. This is the top view, and this is the front view. And once I construct the top view and the front view, what is going to happen now? I basically connect these points, right? And when I connect M1 and M2, both in top view and in front view, I basically get the apparent length. But what we need here is the true length, correct? And how do you get the true length? You get it by drawing arcs, right? So I first take this and I draw an arc from here. Whoops. I draw an arc from this point M1 because now this is an apparent length. To get true length, we of course first draw an arc, and after we draw an arc, we draw a horizontal line, right? This is how you find true length from apparent length to this locus, till this locus, correct? And what happens here is I connect this point M1 to that intersection, and that will give my true length. True length is what now? True length is 84.88, correct? And that is my true length. And we can do it on the other side also. What happens when you do it on the other side? First we take an arc, correct? Oops. First we take an arc. That is my point. That is the arc. And then I take a horizontal line till that locus, correct? And what happens after that? I basically connect these 2 points, and it will give me the same true length. I can find true length here or here. It really doesn't change anything. Now, after we have found the true length, and that's true length is the only thing they've practically asked us here. That gives us the true length, and we have to convert the true length to the true length dimensions, because we've assumed 1 meter is 20 mm. If we are getting 84.88, we have to divide it by 20, and that gives us what? That gives us 4.244 meters, right? So that is the true distance between the two mangoes, correct? So we'll just kind of annotate that here so we can refer to that later. The true distance here, whoops, is given by this line, right? This is my true line, and this is this is 4.22 meters. So that's the answer, right? And that is what we have to look for, and that is what we found too. Oops. All right, so that basically solves the problem. And one thing you have to remember when doing these problems, it could be the room problem or this problem, is you try to first visualize the problem, and once you've done visualizing, you draw the top view and the front views for the problem, and then you basically find the true length or the true angles on basis of the question, right? And this is how you solve for the mango problems.